Greetings, everybody. I'm Larry Williams, the Director of CARMA, the Consortium for the Advancement of Research Methods and Analysis, now in the Rawls College of Business at Texas Tech University. It is February the 13th, and it's my pleasure to welcome you to another CARMA Quick Chat. You may know our Quick Chats are where we take the opportunity to chat a little bit with people who are making important contributions to CARMA. And today it's my pleasure to be chatting with Arturs Kalnins from the University of Iowa. And we're talking to him today in preparation and anticipation for his webcast lecture that he'll be giving 2 weeks from now on February the 28th. Friday at noon Eastern time. And for those of you that don't know about CARMA, we are an academic center in the Rawls College of Business, and our commitment is to provide research methods education resources in support of scholarly research by faculty and students, mainly in management and organization studies areas. And so our tours talk will be a webcast lecture that's offered as part of that program. We've been doing them since 2004. It will also be recorded and will be added to the list of 250 recordings that we have in our video library that are available for viewing. So Arturs, it's great to get the chance to chat with you. So
Great, thank you.
how did you end up becoming a professor?
Oh, well, so to start out, now my dad was a professor. He was an engineering professor, so I knew the lifestyle, and I knew that was always a career option. And I had kind of resisted that initially, resisted the allure of that, but I got an MBA after a bachelor's degree, and was working in management consulting. And after a few years, I just started to think that I enjoyed thinking about problems much more deeply than you necessarily have to satisfy a client. And as I said, at the same time, at the time, this is 25, even 30 years ago, my dad was still a research active faculty member, and so I kind of like saw day to day his lifestyle, and I thought, that it seems like he's like there's more intellectual challenge there than what I was experiencing as a management consultant. Not that it was bad. I had a really great few years at that, but yeah, that's how I decided to go back and do a PhD. And having the MBA, it seemed like business was actually, I didn't know how good an option it would turn out to be. I just kind of thought, okay, well, I've done business, so I may as well do business some more. So
Yeah, yeah, I similarly made a right choice. I was interested in quantitative psychology, and for various reasons ended up getting into a business doctoral program and not really having any idea of uh, how good a life it could
yeah.
be. So one of the things that I enjoy about getting to chat with people in your particular situation is kind of tracing back their interests and kind of what got things going for them. And I just found myself when I was looking at your background and how much work you've done in linear regression, and I just was curious about how you first got exposed to it. And then when you did you have any idea that it would become the focus of some of the research that you've been doing as much as it has been? Because you have several kind of interrelated topics, all related to linear regression. So can you remember back when and where and what it was like?
Yeah, first of all, so my bachelor's degree was in math,
Yeah.
so I picked up all the skills, all the basic skills, but I admit I'd had one like baby stats course as a part of that, so I didn't really think too much of it. I had baby stats again as an MBA student, didn't really focus on that, but then once I in my PhD program, all of a sudden it became a big part of what I was doing. I had all this data on locations of fast food chains in Texas, and was basically using linear regression methods to analyze that. So it became the heart of what I did analytically. But I was at that point, I was strictly a user. It didn't occur to me that I would be contributing anything to it necessarily. But then, even as a doctoral student, even as a doctoral student, I did notice this phenomenon which drove my initial interest in kind of the multicollinearity work. I started noticing, when you're looking at geographic locations of something like fast food, and I was, I was looking at a lot of variables, just of the geographic, demographic variables. So overall ethnicity, income, unemployment rate, a lot of these things end up being correlated 0.6, zero point 0.7. And I just
Mhm.
started, even as a doctoral student, I started to notice this phenomenon that once you put a lot of these variables in there together, some of these coefficients start just bouncing all over the place.
Mhm.
Like one specification are positive, the next are negative. I was really careful to really try to try to at least try to find where the robustness is and where robustness isn't in that. But that being said, at the time, I still didn't have I didn't, I hadn't started to more deeply think about regression analysis, and I just kind of accepted this baseline kind of mantra that people keep repeating, that multicollinearity does not bias coefficients. So I just kind of said, well, okay, I'm just kind of going to make sure I have robustness, but I really don't know I have no better explanation for why this stuff is happening. And so I continued to just, again, really for the first 15, 20 years of really first 15 years at least of my career as a professor, I still just strictly was focused on application and my business geography work for the most part. But I kept on running into this same problem, and I also kept on running into it, like in reviews I was doing, where people are saying, "Hey, this is great. Our hypothesis is supported. We have statistical significance for the variable we want." And I would say, "Yeah, but there's another variable in there that's correlated zero point 0.7 with your variable, that's got a completely unintuitive and opposite result to what you would expect. And surely there's got to be some relationship there." And so from that onwards, I finally said, I'd finally reviewed enough papers like that I said, I've got to just take the bull by the horns on this and figure out what's really going on with this. And I kind of slowly rebuilt my mathematical skills, largely through the benefit of web education. I mean, just things like Khan Academy and the MIT OpenCourseWare. I took a
Mhm.
few of their courses through that and kind of got myself back up to speed where I had been 20 years earlier. And then from there on, that's what's led to. So it's really kind of a second act of my career. And right now I'm just really focusing on that, because every time I do one of these methods papers, like three more obvious applications or ideas pop into my head as I'm working on each one. So it's just seems to be there's more work to be more and more work to be done.
Yeah. So is there, if it's okay, I ask some questions that are kind of follow-up. So is there a particular kind of joy or satisfaction that you find from doing your methods work as compared to your substantive work, or is it sort of all the same in terms of how
No,
you?
no, it's not all the same. I mean, both can be satisfying, like just even putting together a good set of hypotheses and actually seeing that robustly borne out in the data is a very kind of personally satisfying thing. But I think even with methods, maybe that's more so because there's a real elegance to a lot of the underlying methods that we use once you start to understand them very well, and even to just something I'm just working on this morning before I talk to you about this kind of phenomenon of variables that are uncorrelated but not independent. So the idea of like quadratic terms versus a primary term and things, and there's some really kind of elegant little regularities about ways that coefficients, or not coefficients in this case, but ways that standard errors can become biased and things like that. So there's a real elegance to it, that has been uniquely satisfying.
Yeah. So it kind of began with multicollinearity, but then since then, your work in regression has touched on some different kinds of methodological aspects of it. Is there kind of a progression, or was there a flow of interest that led from one topic to the next?
Well, they're all still multicollinearity is kind of at the heart of a lot of these things,
Yeah.
and yes, and then it slowly branched out from that. I mean, like I said, the project I'm working on right now is actually it's about interaction terms, and it's about this repeated finding that methodologists have found that these things are being supported interaction. We're finding interaction results in cases where we should not have the power to find them, and why not?
Hmm.
And so there's pretty big literature on that. And so something along the way when I was doing my multicollinearity work, I discovered as an aside, why that could be. And so it all kind of these other projects stem from like things that I observed doing that work. And yeah, and I've got a number of other things in process, about, another one about something I know a lot about also, which is common method problems. So,
Uh-huh.
so that too is something, it comes from the work on multicollinearity, and now I'm kind of expanding that, but I'm finding a lot of I suppose the basic mathematical toolkit that I've built up in working on the multicollinearity problems, I find are also very often that's a toolkit that can be tweaked a little bit and modified and then applied to these other types of problems. So and I think can result in some rigorous findings that I think are non-obvious and yet are useful.
Yeah. So, from a lot of us that are involved in doing methods research, we also teach research methods, and there's kind of this interplay between our topics oftentimes that we study end up emerging from teaching. So do you teach linear regression or anything?
I do not. I do not, and I never have, and I have actually. I've told I've told our department chair and deans that whenever they'd like me to do that, when and if they'd like me to do that, but I'd be happy to. I suppose actually, what's overall a good thing, but unfortunate in that regard, my department happens to have several very good methodologists. So,
Uh-huh.
so we have other folks covering all those. I think covering those topics very well. But yes, I would love to at any point in time. But no, I have never. I've been always teaching. Whether it's bachelor's, master's or PhD, I've been teaching strategy uh,
Uh-huh.
pretty
Yeah.
much through my career.
So, well, that you must, even without teaching those students,
Yeah.
you must kind of have an interesting perspective as you watch them and see what they have learned from regression in their coursework and see what they learn and what they don't know. So, what is it do you think when students get their initial management, where our main audience is management researchers, or what are they not getting out of their regression courses that they should in terms of really getting a type of a depth of understanding that will serve them well?
That's I mean, it's a difficult question, but I can just think of some things. I think there's still there's perhaps I think there's an attitude sometimes that methods are just kind of a necessary nuisance, and that they want to prove what they want to prove substantively, and or demonstrate things substantively, and that you just say that, oh, everybody else is doing such and such method, I'm just going to throw together that method because everybody does it, and I just put it in the paper and that's it, and I get my statistical significance. And so what I do wish, and I think is that people would really start to look at just methods as really kind of the really fascinating and elegant thing that they are. And also, if you have methods can be, as I'm sure can be very easily abused, um,
Mhm.
get the results you want, not necessarily that they're really there, but they could, is the old joke about, you torture your data until it confesses.
Yeah.
And I think if people, not that most people are kind of necessarily purposely doing that, but it's kind of like, well, they find something that works and they just want to stick with it. And I think if you have a little deeper relationship with the methods, and I think a lot of it just comes from just exploring things, just keep on trying to use different specifications, looking at raw correlation tables, looking at how your results have changed once you started to include control variables relative to what's in your raw correlations. I think just developing a real depth of and appreciation for kind of what those methods are telling you. That's the kind of thing when students do ask me, I really try to tell them to, don't view methods as this, as a nuisance or even kind of, a necessary evil or anything, or just a hurdle, that you just want to get across. I think if you kind of really engage more deeply with it. And it doesn't have to be deeply in the mathematical sense of being, a
Right.
Nobel Prize winning econometrician, but just really understanding your data and understanding how kind of, and again, just through trying many different specifications, trying some different methods to demonstrate whatever you're doing, making sure things, look pretty similar no matter how you do them. I think that's the kind of thing I like to promote when I speak to students. And I will say, I want to credit my longtime friend and colleague, Miles Shaver at Minnesota, who I thought had a really brilliant statement that he answered to his students once when he said, student was talking about, well, look, these control variables are in there, and now I got my result and everything. And Miles said, he said control variables should be used to make sure your results don't go away. They should not be used to make stuff show up.
Yeah. Yeah.
And I just thought that was brilliant, and that was just the simple kind of thing. These are the simple kind of, I think, I don't know what you call them, little simple pearls of wisdom, that if you can kind of keep that in your mind, that kind of, and show a little humility, then I think you'll end up with some results that are really when you get them, they're quite meaningful. Doesn't mean you're always going to get what you want, but when you do, it's going to actually be a meaningful thing.
Yeah. Well, we've been very, very thankful to have Miles give a couple of Karma webcast lectures. So he's a friend of Karma. I think, one of the things for me with my students, that there's this notion that they are naturally inclined to have, which is that they're going to learn everything they need to know about methods or statistics within their particular coursework or their doctoral program, when in fact it really is, it has to be kind of a lifelong endeavor, because as you go through different substantive projects, there's going to be different methodological nuances related to what you're doing, and you have to really be open to exploring and trying to understand and get the best find the best solutions to the problem. So, well, you must have, given your experience, you must have an interesting lens through which you look at applications of linear regression in the journal articles that you review. And so when you read these, is what frustrates you the most about the state of application of linear regression in management research? What are the most common mistakes? What do we need to be doing better to get more out of the tool?
I would say, again, kind of goes back to what we were talking about regarding the students. A lot of that methods should be present, and your regression should be specified very consistently. I don't know how many papers I've reviewed where they test a few hypotheses, and then with one specification, and all of a sudden they're using a different dependent variable. Then for no good reason, all of a sudden several of the variables disappear and some other ones appear in their place. Sometimes that's driven by necessity from what the dependent variable is, but other times, as far as I can tell, there's absolutely no good explanation for it. So I would say, what I like to see is when people remain consistent in kind of what they're doing. I also like multiple specifications. I don't, particularly things also drive me nuts. Like if you're getting like instrumental variables are great, two-stage least square is great, but before you do that, also show me what the OLS is going to show you.
Mhm.
Don't just show me the one thing that the one, hyper specialized specification that leads to the result you want, but take me through the steps. Like if you're going to tell me there's endogeneity, that's great. I mean, I'm fully supportive of trying to control for that, but show me what the OLS does, show me why that's a problem, and then move over and show me what happens to it after you say use an instrumental variable. For example, that's just an example, but things like that, like show me as much as you can about the process. um, and like I said, I think, and that's why also too, I love correlation tables, and this is a battle. Sometimes I have also published occasionally in economics, and know some folks over there, and that's a battle I always have with them. They think correlation tables are a total waste of time, and I say no, they're really not, because you can really see, just going back through that correlation table, you can immediately also, it would flag, multicollinearity issues, but you'll immediately see things like, well, what is the raw relationship between what's the supposed independent variable and the dependent variable? What's just that raw relationship? And then you can see from there, okay, once we add controls, how is that going to change? So that's what I love. I would say it comes down to, like, provide me with more information as opposed to less.
Uh-huh.
And multiple specifications, and just to the point where I'm comfortable that okay, this is, ultimately what's going on here is what you say it does. What you say is actually what's going on.
Yeah. Well, as I mentioned earlier, we're chatting today because of your webcast lecture in a couple of weeks. Let's close by having you give us kind of a preview of what you're going to be talking about.
Okay, well, what I plan to do is just to, I have been publishing on the multicollinearity issue now for about 6 years. From my first 2018 paper that came out in SMJ, and subsequently I have a few ORMs that touch upon it and build upon that work. So I kind of plan to do an overview, because I think still there's a lot of folks who aren't that aware of it, or so first of all, I want to kind of I want to present the basic idea why multicollinearity, yes, it is a problem, and it's something you need to be worried about, and just trotting out the phrase that multicollinearity does not bias coefficients, that's not going to fly with me, and it shouldn't fly with anybody else either, because that relies on your regression specification being otherwise absolutely perfect. And yes, if you've absolutely perfectly nailed the phenomenon of interest with every variable measured perfectly, then yes, multicollinearity is not a problem. But as soon as you have other issues, it is a problem. And so that's the one thing I want to get across. And then with that is, okay, what do you do about it? And there's no simple magic bullet to this. I have a recent ORM also on this VIF score that people love to cite for why multicollinearity does not matter. So I do plan to just spend a few minutes on why that makes no sense at all to use. That's just a myth that has been propagated, and I guess it makes people feel good about themselves when they run it, so they kind of keep on running, and it just becomes such a norm that everybody does it. So I want to talk about why that and things like that don't work and shouldn't be used. And instead, what I'm going to argue, and maybe is that really just have some thoughts again on research and hypothesis development, and just showing a little humility, and not trying to be overly tricky with the hypotheses you're testing, and not being overly convinced that non-intuitive results that you may get are in fact these great new findings that call for a whole new theory development, because often they're just type 1 errors, and they're caused by multicollinearity. And in the case of a non-perfectly specified regression, multicollinearity just causes a lot of really wacky results, and I think a lot of them do get weeded out in the review process, but I think quite a few don't. And so that's what I kind of want to go back to is, and again, there's no magic bullet. There's no silver bullet that just allows you to kind of dismiss all these concerns. Just, show a little humility, and try to present the several different specifications, and see how robust your results really are.
Yeah. Arturs, Kalnins, we will look forward to hearing more from you in 2 weeks on this important topic. Thanks so much for spending
Yeah.
some time chatting. Karma webcast lecture, Friday, February the 28th, noon Eastern time. Hope you can join us. Thank you, Arturs.
Okay. Thank you, Larry.